do that and then quickly backtrack for those people. So the people that joined a little bit late, I put into the chat a link that I'd like you to go to if you want to follow along on this sort of, demo that we're going to be doing on the Mimic data set and how to use electronic health record data. So if you go to the link, you're going to go to this website. This is a tutorial generated by Dr. Supreet Sushkumar, who was one of our postdocs, since graduated. So many thanks to him. If you go to this website, it just gives you the exact steps you need to do, which I'm going to take you all through. The first thing is to go to this jupyter.org try thing. And this long-winded answer you heard me talk about, what I was talking about was Jupyter and platforms. It opens up this web page, or sorry, I should say, when you click on the Jupyter try link, when you sort of click on, oops. Man, how do I use this thing now? Oh, here we go. All right. When you click on, oh. When you click on this jupyter.org try, it's going to open, you go to this other tab here. And then same deal, you're going to click on try Jupyter Lab. Okay. And then when you do that, it's going to take you to this screen here in a second. And then what I'd like you to do, again, you don't have to if you don't want to, but if you'd like to follow along, and again, I'm going to go back to our more formal introduction of what Mimic is and what this electronic health record data is, but I'm just trying to get this part done to get you guys set up. So go ahead and click on that, go into this next section here, and then follow these commands. So I'm just going to walk with you through this whole process, okay? So the official command here says, once you get into it, click on File, New Terminal. So again, in this interface, you can go up here and say File, New, and then Terminal right there. Or you can click on this icon here, right here, where it says Terminal. And when you do that, it is going to open up this old-fashioned text interface. And again, for those that may not have interface with a computer system using a text interface, I'm just going to go over a few of the things. It's fairly straightforward, but I'm happy we'll answer questions through these steps as we do them. Okay, so again, and then go ahead and go through some of these next steps. So I want to show you a little bit of this Jupyter interface. And once I show it to you, I'll pause to make sure that we're all on the same page, okay? So the first thing to note is that, number one, this is the terminal, all right? I'm going to teach you a couple real quick commands that are really helpful for working with a text interface on a computer that uses a Unix or Linux system. The first one is just called ls for list. It's going to list all the files within your folder that you're currently in. And these are the names of the files. For a more traditional view of the files, you will see here on the left-hand corner, like a more traditional folder view of everything. Okay, but I want to teach you one other thing that can be confusing about a Unix or Linux text interface, and that's just figuring out where you are. Like within our traditional folder system, like it's a little bit more obvious. You have visual cues. Oh, I'm in my documents folder. It can be a little bit more challenging in the text interface. The other command that I like you all to know is called the present working directory command, or PWD. So if you just type in PWD, it'll tell you I'm in /home/ this thing called Jovian. That's just something, it's just the one that's made up for this demo tutorial thing. Now, how this links back to your visual file tree is this root folder in the tree. So let me highlight this again. So over here on the left, you see this little folder icon. I'm going to go ahead and click on it, right? And this folder here, right here, this root folder is where I am here. In fact, when I typed my ls command, you notice it says I have the binder, data, demo, license, etc. And notice it's the same stuff over here. Also notice in the text interface, anything that's a folder is highlighted blue. You see here it's a folder in the regular folder visual interface, and other stuff is just looks like regular text. Okay. What we want to do is now go back to, let's see, where were we? We were, I think, in the demo directory. Nope, not there. Hold on one second. Okay. Well, actually, what we're going to do quickly is, I just want to make sure this won't break anything. Nope, no, it should not. Okay. So within this root folder, so everybody should be in /home/joyvin. Again, the way to check is the present working directory right there. And then remember, just because you're in the directory in the text interface, just a heads up, that will not automatically update the graphical interface. So don't assume that if the graphical interface says that you're in the root folder, that you're going to be in that same place in the terminal. But we know we are in the root folder because it told us it's in the /home/whatever. Now, your thing after home may not be Jovian. It might be some other name because these names are being made on the fly. But at any rate, that's where you ought to be. And then all you got to do is do this. So go back to this other web page and then select this little line here, literally it's where it says git clone, and then this website. So I'm going to copy this. I'm going to copy all of this. Go back to this, and inside the terminal, I'm going to paste it, which you can do with a Control V, obviously on Windows, Command V on a Mac. Or you can go up here to edit. Oh, there is no paste option. So you'll have to do Control V here, or you can just type it out. If you don't want to try to copy paste, all you can do is you can just type it out. But I just sort of pasted it in there. I'm going to press return. All right, now it did some stuff and you're like, hey, what in the world did it do? Well, what the git command is doing is it's going to that website and it's downloading that stuff. Someone said right click should also paste. Yes, depending on your interface, right click may paste. Because this is in a normal terminal environment, but because this is a terminal environment being emulated within like a website, I'm not sure if right click will paste for you or not. So if you know how to like deal with it, by all means, please just go ahead and type out the command or paste it. However, for those that may have issues, like I said, you can always type it out. Just type it literally in here, git clone, etc., etc., etc. Or just paste it and then press return and a bunch of other stuff. And it says cloning into a Brian workshop. What does it mean? Well, it's going to this website, it's downloading this stuff, and it's going to do some stuff and put it into this folder that we were in. Oh, how do we know what it did? Hey, guess what? We have the ls command. So we type ls, and all of a sudden we see this new folder pop up called O'Brien Workshop. And also within the graphical interface, we also see this new folder called O'Brien Workshop. This was not there before. This was not there before. That appeared because of this git clone command that we just did. So we want to now see what's inside the workshop. So obviously, in the graphical interface, just like we're all used to, you can just double click on it. Within the text interface, the way to change the directory is with the change directory command, which is conveniently called cd. So I'm going to cd, I'm going to type the name of the directory I want to change to, which is O'Brien Workshop. Okay. And again, what's in this folder? Our old ls command. There it is. So the entire folder right now just contains one file, which is actually a file with Python code in it. I'm going to teach you one other useful thing for the CD command. So you might say, okay, well, I'm in this O'Brien workshop folder, but what if I want to go back to the root folder? All right. So the CD command has, or actually any command, but in this context, the CD command, if you want to go one folder up. So for example, I think most of us have seen like within Windows or a Mac, like a little way to like say, hey, take me one folder up. Within a text interface, the way to do that is ... No spaces, just CD space ... In these terminal situations, Unix and Linux represent one folder above or the parent folder. So if I do the ls command again, hey, here I am. One other nice thing about these terminal interfaces is that they provide tab completion. That means I can start typing out the name of the folder, and then if I press tab, it'll fill in the rest of it because it knows that, hey, I'm trying to CD into something, and I started with O'Brien, so it knows the rest of it, and here it is, okay? So again, before I go into the next steps, I'm going to pause, see if there are any questions. Please totally feel free to ask questions if you're having problems. I know we're just sort of throwing you into the deep end of the ocean, and if you're not as familiar with some of this stuff, you're absolutely like in a welcoming place to ask questions. Okay, fair enough. So then moving on, this is actually the code that we're going to be using. And ironically, in a weird sort of existential conundrum, this file that we downloaded is literally this file. And I'll explain why in a second. One thing we want to do now is actually open this file that we just downloaded. All of you see it here in this O'Brien workshop. We actually want to open it within our Jupyter Lab interface, okay? So I'm actually going to go back. The easiest way to do this is go back to our graphical folder view and just double click on this thing where it says sepsis prediction version 1. And when you do that, it's going to open it up. And please note that this file is literally the file we started off with, that link I pasted in the chat. But this is really important. You will not be able to follow along and run the code if you try to use the website link that I just posted in the chat, okay? So this actual website, so the thing that I actually posted in the chat, this little tab up here, blah, 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 this is good for a point of reference, but you're not actually going to be able to execute any code here. You have to be within this Jupyter Lab interface thing, okay? And even though you're just opening the exact same file, you got to be in the interface to actually execute code. So just pointing that out. So now we have the code. Now notice a couple of the things. When we did that, it automatically opened a new tab. So you see the tab here for the file that we opened, and we see our old terminal tab here. So what I'm going to do is we can always swap back to the terminal tab to type more instructions. So one instruction that is asking us to do is to go ahead and say, download the data from the Mimic website, okay? So the first thing it says is CD to the O'Brien workshop. We've already done that. We know that CD means change directory. We can always make sure that we're in the right directory. Once again, with the present working directory command, pwd, it says that we're in the right place. And then it says, download this data set. And again, here's another one where you could just type it out from scratch. But if you wanted to, I'm just going to highlight the whole thing, wget, get that whole thing, Control V, go back here to the terminal, paste it, and execute it. All right. wget is just a little shortcut in Unix and Linux to be able to essentially get stuff usually from the internet or any sort of resource that's accessible from the internet. It's just going to download it. So again, what did it download? I can type the ls command, You can see it downloaded the zip file. You can also see it within our graphical interface. Next thing to do is simply unzip it. So there's a command here that says unzip training set b.zip. Again, go back to my terminal. Go ahead and do that. And then it's going to unzip a bunch of these data files. So with that being said, I'm now going to take a step back and talk about what in the world did we just download? Like, what was the point of all that? So again, I'm going to pause for a second just so that everybody, again, if you wanted to follow along, was able to A, access the code, and B, download that data. You shouldn't need any special permissions or anything. All of you should literally just be able to click on that link. But at the same time, if you're having problems or something isn't working, please speak up. Okay, great. So what is Mimic, right? So one of the biggest questions people have when they get into clinical informatics, data analysis, data science, is how do I get a hold of this data? So some of you are going to be working with clinical data, and you've noticed that you normally have to go through lots of steps and procedures to gain access to patients' data. And that's a really important take-home point about clinical research in general and informatics research. If there's any lesson that I want you to know at the end of this summer, is that healthcare organizations, including UCSD, work very, very, very hard to protect patients' data, to not allow people to use it fraudulently, to use it without permission, and to use it for legitimate purposes. UCSD, if you happen to get your care at UCSD, will actually allow you to sign a blanket statement that says you do not want your clinical data used for any research purposes at all without your explicit permission. Because otherwise, your clinical data can be used anonymously for clinical research after appropriate approvals have been submitted to the IRB, which is a process all of you know about after doing your city training. Now, Mimic is unique. So Mimic has been around for years. Mimic is an actual clinical data set from 2 hospitals in the Boston area that have thousands of patients in it. Real data, it's actual patients' data. Most of this data is for our patients that were in an intensive care unit. And the reason the people from Mimic are able to distribute this semi-openly, right? So you can't, it's not just anybody can go and get this data, but importantly, anybody can ask for the data, like literally anybody, including all of you on this call. Even if your research projects have nothing to do with clinical data, but at some point later down the road, you're like, hey, I'm really interested in a project, but I need some clinical data to test it out. Or I'm interested in maybe writing a software or an app, and I wanted to test it out with some real clinical data. How can I go about it? So you can do it by going to the Mimic website. So I'll briefly go there. I'll put the links in just a second. Hold on one second. So what you want to go to is physionet.org. You'll end up clicking on data. Now, the Mimic people are not just going to let you download all their data willy-nilly, even though all the data set is what's called de-identified. That means the patient data should not be identifiable, at least according to federal regulations. You do have to do extra process. And in order to do that, the main thing you have to do, and I'm not going to do it all right now, you can read the directions or contact me offline for help, is that you have to finish additional city training. So remember when you did our city training for us, you had to say, hey, my city training is for doing research at the University of California at San Diego. Similarly, if you want access to the actual Mimic data, the Mimic people will expect you to do city training that's specific to the Massachusetts Institute of Technology, MIT. They have all these directions on their webpage. I'm not going to go into it right now, but I'm just letting you know that you yourself can gain access to this data. The data that we're downloading now is a very, very small subset of the entire Mimic database that is specifically meant for tutorials. So the Mimic people have released a super small, super de-identified version specifically for activities like this, such as tutorials and such. So again, that's what you downloaded. And then going back to the PowerPoint. So as I mentioned, what's actually in the Mimic data set? So, but the Mimic data set, and I think I showed you some basic examples of this, of what a database looks like on the back end. A database is a bunch of essentially Excel tables that are organized. It includes information. The Mimic data set includes information that, once again, is very, very similar to how clinical data is organized at any electronic health record system, including Clarity, which you heard about from Dr. Pierce yesterday. So the Mimic data set has demographic information about people. It includes vital signs information, measurements, such as height and weight, laboratory tests, procedures that were done, medications, actual clinical notes, and what happened to the patient. Primarily, did they leave the hospital alive? Did they die in the hospital, or potentially die shortly after discharge? Some limitations, again, it's limited to primarily patients that were in the intensive care unit. So if the situation that you're studying or trying to do research on, or whatever it is, does not involve patients in an intensive care unit, it's not quite as good a resource for you. But it's still a good resource because it allows you to gain exposure to electronic health record data, because even patients not in an intensive care unit will have data organized in this format. Here's just some basic information about how to navigate the Mimic dataset. You're not going to need to know this for the tutorial, but just FYI, all patients have something called a subject ID, which is an anonymous identifier. It's like not their name or social security number or anything like that. It's just a random number that's not, you can't tie it back to an actual person from the Boston area. It has this other thing called an HADM ID, which is just basically a hospital admission ID, again, an anonymous identifier. You'll find it in all the tables within Mimic. As I mentioned, each of these tables have some basic sort of organization. It's very similar to how data is organized within other real-world electronic health record systems. So here's just some general metadata about patients. It has stuff about, in terms of actual times that they came into the hospital, the date, the time they came into the hospital, the time that they left the hospital. Because this data is primarily about patients who are in the ICU, it has a special table that is specifically devoted to data about patients about coming into and leaving the ICU. Some of this other stuff is less relevant, but it may be, but it's just, my point is there's just sort of what we call metadata about what happened to the patient and their stay. But most of what you're going to be wanting is what's called the actual clinical data. So the clinical data is divided up into separate tables within Mimic that have to do with what they call chart events, daytime events, node events. So all these different tables have different components, things like laboratory results, radiology tests. We talked about some of these things in that lecture last week about ontologies, how data and clinical data is organized. And the way it's organized is because any individual hospital may have their own way of talking about a specific blood test, like testing someone's hemoglobin or their blood counts. The way San Diego internally talks about it may be different than the way that these Boston hospitals talk about it. And in order to overcome that limitation, what healthcare organizations try to do is map all that to a common ontology. Does anyone remember from our lecture last week what that common ontology was for laboratory data? I will buy you a Snickers bar if you can tell me. It's called the LOINC ontology. So the LOINC ontology is the one that captures laboratory data. So all the data that's in Mimic will have not only the name of the lab test and an internal identifier, but it also has the mapping to a LOINC code, which is an internationally recognized ontology. Again, the reason that's important is because if you're practicing and developing something based upon mimic data, if you use the LOINC code for the laboratory value or whatever other ontology for different types of data, you'll be able to go back and use that exact same code in theory with data at another healthcare institution such as UCSD, as long as you're using the ontologified version. So unless someone has already mapped that data to that specific ontology. All right, so that's just a general overview of Mimic. And now let's go ahead and go into like a brief tutorial of what analyzing healthcare data looks like. Again, some of this code is going to be confusing, and this is not meant to be a tutorial on learning Python from scratch. And I'm going to show you how to interact with this code in a second, such that you're not actually going to be writing code or trying to learn all the aspects of it. But I did want to show you just kind of an end-to-end workflow of how one does work with electronic health record data. So before I do that, again, I'm going to pause, see if there are any questions about Mimic or anything else. All right, sounds good. Going on, again, you're going to want to be within the Jupyter lab, okay? So this is not going to work if you just clicked on the website link that I posted in chat. You need to be in this Jupyter lab interface. And then within the Jupyter lab interface, you need to be in the sepsis prediction Python notebook. So I use that phrase Python notebook. What does that mean? So again, Python is a programming language. The Python notebook is this interface that allows you to mix text, like regular stuff, pictures, text, whatever it is, along with little sections that execute actual computer code, right? So this little sections in gray are actual Python code, and we're going to be able to actually tell the system, the computer, to run that code. There's a couple different ways to do it. So if you click on that little code, and these little sections are called cells within the Python notebook interface, so just like that parlance, it's called cells. If you click on the cell, there's a little play sign up at top. Again, let me highlight. So play sign up here. You can click on the cell and then click little play sign, right? Notice how this little blue bar advanced to the next cell when I click play. Another shortcut in order to execute the cell on Windows is just Control and Enter. If I do that, it's going to execute that cell as well. I think it's going to be Command key and Enter on a Mac. All right, so the first cell is just basically saying, remember I said Python and R have all these other packages that people have developed. One of the most common packages for Python is called NumPy. It's basically opening that package and saying, please use this package. This next cell, we're just going to execute again. And all this is doing is creating a function which allows you to do something. So all this thing does is load the data. So load our challenge data. All right. So this next step at first looks pretty confusing and it's a little bit challenging to follow. So this next cell has a bunch of code in it. So let me see, first of all, if I can zoom in a little bit. All right. So all this stuff is doing, even though it looks really confusing, all this stuff is doing is opening up. So remember how we opened up this data and we had this folder called training set B? We downloaded this data from Mimic, this practice data. And if I cd into that folder and again type the ls command for list, it has all these files. You know, it's got all these files worth of patient data in it. It just so happens that's the way this data was organized. So all this little code section is doing is saying, okay, open this directory called training set B, find me all of the files within that directory, okay? As you can imagine, this thing says, tell me how many files did you find? This is going to be a little bit tougher to explain, and this is going to be easier to understand like later in this summer internship. But in a general rule, within any framework in data science, whether it be statistical, machine learning, or whatever it is, we frequently have a concept of building a model and then testing a model on data that is different than the data we use to build the model, right? And we can get into later as to why that is. But all this is saying really is, all right, we found all of these files worth of data within this directory. We want to assign some of these files as what's called training files, or data that we can use to train a model, and testing files, or data that we can use to test a model. So all it is doing here is going through that, each of these files. And again, this section here, all this is saying is for each of the files that we have demarcated training file data, open the file, read the data, and then create a big old data set with all that data in it. Okay, so all you should need to do is select this cell again, and then go click on that little play button. Now, please note, it might take a second for it to open all those files and read them. Okay. And you might know that it's taking a second because in the Jupyter Lab interface, when the system is taking a second to execute code, there'll be a little dot next to your tab for your Jupyter notebook. So it might be taking a second. The other way that I sometimes look to see if the code is still executing is a little tip. Even though you are not the ones that wrote this code, it is totally safe for you to experiment and edit it. One of the nice things about this Jupyter Lab try thing is that you can literally write any code you want and play with Python and never mess anything up, because this whole environment is totally temporary and gets deleted when you close the tab, like this main tab up here. So I can actually make my own little code cell. So let's say I executed this code and I want to see, okay, well, what did all of that do? So right now, I know the system is selecting this next cell, which is not code, it's just text. And again, the reason I can tell that is because there's this little blue bar here that says that, oh, this Python notebook is in this next section. What I can tell it to do is open up a new code cell right about this. And the way I can do that is within this interface, I'm going to click on this little plus sign. And in this situation, it actually open up a code cell below it. There's a whole bunch of like little keyboard shortcuts. I'm not going to get into that now. If you're interested in Python or Python notebooks, you can look it up. But anyhow, I open up this little code cell, and the whole point of all this computer code up in this cell was to create test data and train data. Well, what the heck is in there? Well, I can actually find out. So if I can type into this code cell train data, and again, I'm going to go up here and press the little plain sign. It's going to take a second to show me that train data. So normally it would show me right away. But the fact that it did not show me right away, again, is an indication that it's still running all the commands from this one major code section here. And again, we had a hint that it's going to do that because of this little black circle here. That's an indication that Python is thinking or working or chugging through stuff. But as soon as it finishes executing this code, this little circle ought to clear up. And then in this next code block should execute, and it'll show us what's actually in train data. So again, it's going to probably take another couple minutes. So I'll just pause there again, see if there's any questions. Okay. Right. Notice that little dark circle disappeared, hopefully suggesting that it executed all the stuff in here successfully. So again, I'm going to go to this new thing that I just made right here, the cell, where I want to see what is inside train data. I'm going to press the little play sign. It should show me what in the world is in there, assuming there aren't any issues. There's also a little stop sign to troubleshoot problems should they arise. So I'm going to do that and say kernel, interrupt kernel. So a couple little tips if you're having problems with the code and something isn't working quite right, you can try pushing a little stop sign here. In the worst case scenario, you can go up to the menu up here and go to kernel and say interrupt kernel, which I'll try to do. And let's see what's going on here. I'm going to pick up one of these other variables that it hopefully has opened. And that one's also having problems with. So I'm not sure why that is. So I'm going to do something real quick. I'm going to say restart kernel. Same thing. I'm going to open this file back up from scratch. And tell it to restart the kernel. It does. And I'm going to basically do everything that we already did. So go from the top, define those things, get it, get that, and then read in the data. Again, we'll just take a minute to read that in. Sorry, I'm going to do something real quick since we're short on time. What I'm going to do is I'm going to change the number of files, number of data sets it's trying to read through, because it's trying to read through a fair number. So I'm going to delete some of the stuff that it maybe doesn't need. I'll probably need one more than that. Hold on one second. Okay. Secure files, perfect. All right, I'm going to go back into my thing. Open up my notebook again. Make sure my kernel is fresh. All right, execute. All right, Notice this little circle here disappeared. Go to the next one. All right, what does the training data looks like? So again, for most machine learning tasks, it's generally going to, what it's going to do is it needs to convert everything to some sort of numeric representation. So our training data is essentially going to be a matrix of numbers. So the matrix of numbers is going to be each row is a patient that was in the ICU. And then each column is some laboratory task or some sort of information about the patient, right? And similarly, I'm not going to get into this aspect here because we're a little short on time. This is some basic pre-processing that the training data has to go through. If you follow through some of the links we emailed about the basics of using R and pre-processing data, it'll go into some really nice basic tutorials on what needs to happen when you open data and pre-process it. So I'm going to click play for now, just to go through it. And then we'll talk about briefly what it's doing here. Okay, so what this is doing is a very simple model. So all this model is doing is saying for Python, and like I said, this is very similar to any sort of analysis pipeline. The way this data set is going to be structured is that, as I said, each row is going to be a patient. Each column is going to be some information about this patient. What this is trying to do essentially is to look for something that happened to the patient. So in order to do that, the way it's going to structure the data is that one of those columns is what we call the outcome. So whatever it is that we are trying to predict or model, let's say whether the patient died or didn't die, did the patient go back straight home? Did they have to be transferred to another hospital? Whatever it is. Within this context, it's a multinomial regression. I forget exactly what the particular outcome of interest here is. It's a little bit irrelevant, particularly for this particular situation. What this is telling us simply is that, again, we saw this interface before, that there are all these packages for Python. We are using one of these packages and a very specific part of that package that allows us to do logistic regression, which is a very fundamental modeling tool for lots of health sciences research. And it's surprisingly powerful. Logistic regression has been around for decades. And for lots of different situations, logistic regression will work surprisingly well compared to many other modeling technologies, including really advanced, sophisticated technologies such as neural networks. But for now, the system is saying, hey, I want to use logistic regression. I'm not going to go into all of these options, but all this is saying is I want to use logistic regression. But when I use logistic regression as my model, my overall model, here are some specific options I want you to use, that is, say, talking to Python, when you try to build my model. So I'm just going to click play here, and it's going to go through. And again, it's going to take a minute to build it. It's going to take this data and it's going to build a model based upon it. I know we only have a few minutes left. So again, I'm going to pause for a second. And while it's building the model, see if there are any questions. Feel free to unmute yourself or write it in chat. Okay, sounds good. So it built the model. Then it's going to go in here. The next section is called model prediction. So all this is saying is, hey, you built, remember up here, we created a separation between what we call training data and testing data. So when it did all that, it's saying, okay, it built a model. Sorry, just checking out something. It built a model based upon this training data. And how did it work on data that it's never seen before? So we split our original data set into patients that we trained the model on. We're going to test our model on patients that's never seen it. And we did that at the very beginning because we split those files up into a set for training and set for testing. We don't have time to talk about performance metrics. Some later point, I'm happy to. But the rest of this script, all it does is it takes that data, and it plots some information and calculates information about the performance of this model. Again, we don't have time at this today to talk about what all this means, but these are some very basics on how to build a model, and these are basic metrics that we often report when we test the performance of model on really any model. In this case, these are common metrics that we use on healthcare data. So again, I know we're on the hour, but I'm happy to stay if there are any questions. And again, you are welcome to try this on your own. You can open that link and use that link at any time. 100% is, like anytime you're at home or whatever it is. If you want to like play around with it, you can. And again, when you download this script and download this data, you can edit it however you want. There's no danger. Just one thing, please do not redistribute that data that you're downloading. Please only download that data within this Jupyter Lab framework using that wget command. Please don't distribute it in the sense that download it locally to your computer, like on your laptop or whatever. Because again, that data that is a super small subset of the mimic data is still real people's data. And even though it is technically what we call de-identified, that means there should theoretically be no way to say, oh, that's Bob. That's Bob when he was in the ICU in 2007. Even though that's theoretically true, the mimic people distribute this data with a specific understanding that you are not going to be treating it unfairly and not risking getting it out into the open, even if the risk of re-identification is very low. All right, any questions, anybody? Okay, well, thank you very much for your time. Hey, Stephen, I said that you had a question. Oh, you already left. Sorry, no worries.